Hi class, lesson number 2. Hopefully everything went well with lesson number 1. You did your homework. If you had any questions, just send me an email and I would email you back and help you out. So let's work on lesson number 2. Lesson number 2, we're going to be working on all of these things here. Let's go through them. Descriptive statistics. Basically we're going to be covering all of these statistical things that are needed in a regular stats class. So we're looking at the mean, the median, the mode, quartiles, percentile rank, the upper and lower fence, which helps us find outliers. We're going to discuss that in a second. Range, box plot. Box plot is also called box and whisker plot. Items needed for this particular lesson is your TI-83 calculator. And let's scroll up and let's give some definitions here. So the mean is the average of data. Some of this stuff is probably review for you, but we're going to go through over it anyways. Mean is the average of the data, so you add up all the data and divide by the number of data. The number of data is called N for number. We're going to be using that number for the rest of the semester a little bit. Let me see if I can zoom in just a smidge here. Okay, the median is the middle value of a ranked set of data. Sometimes we have to rank data, sometimes we don't. For a median, we have to rank them, we have to find the middle. The mode is the most repeated piece or pieces of data, and if no data repeats or appears more than once, then the data has no mode. It's possible to have more than one mode. You can have as many modes so long as they're ties. If the highest the data repeats is twice, then whatever repeats twice will be the mode, and etc. Quartiles. A ranked data set is broken into equal quarters. Percentile rank, that's the percentage of data that is below the given data value. And the formula for finding percentile rank is there. Range is highest minus lowest. Interquartile range, that's with the quartiles, highest quartile minus lowest quartile. And then the upper fence, the lower fence. And finally, outliers in general. The outlier definition is any data in the data set that is higher or equal to Q3, or any data in the data set that is lower or equal to Q1. So I know I went through that quick, but that's just a reference for you. And what we're going to do is we're going to do, I believe, 3 or 4 examples. We're going to do 4 examples where I'm going to try and find all those values for you. And hopefully by the time we get through the first couple, you should be able to have no problems finding all of these values. So here we go. Here's a nice example for us here. Okay, so we have a random selection of grades from a sociology class. And the grades are 80, 82, 96, etc. And we want to find all of the things that we just talked about just a second ago. So here we go. Find the mean. Now, it's important that the symbol for mean that we're going to use throughout this entire course, symbol for mean, is X with a bar on the top. That means mean. So on an exam, I'm not going to ask you for the word mean right here. I'm always going to give you the symbol. Now X, see in statistics, X just means any variable. The mean is really the bar on the top. Like for example, if you were in a physics class and you wanted to find, let's say, the average velocity of something, they would denote the velocity with a V, and then the average would be the bar. So the V obviously stands for velocity, but the bar is what means the average. If you were in a chemistry class and they wanted the average temperature, they would denote temperature with a capital T. They would put a bar over it, which represents the average. And it's a language, like any, math is always a language. Statistics has its own language. And, I'm trying to teach you a little bit about symbols, so you can just use the symbol and people understand what you're supposed to mean. You don't have to put a lot of words to it. We could have average time, we could have average any kind of stuff. So little t is usually time, and the bar means average. So for this class, all semester long, we're going to keep the letter X. We're not going to change the letter X under any circumstances for each different problem. We're just going to keep it generic, and then we're going to put a bar over it, which simply means the average. So for part A, we want to find the average. So that average is going to be add up all the data set and divide by the number of data. So let's see if we can do this here with our calculator. So we're going to add up. We have 80 and 82 and 96 and 57 and 52, 74 and 70 and 81. It looks like I made a little boo-boo there, so I missed the 70 on the 70. Okay, 80, 82, 96, 57, 52, 74, 70, and 81. There we go. So our total is 592. And we're going to divide that by the number of data that we have here. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to divide that by 8. So 592 divided by 8 is going to give us back 74 right on the button. So that's the mean. That's equal to x bar, another name for mean. Okay. Part B. Part B says find the mode. The mode is the most frequently occurring piece of data. So we're looking to see if anything repeats itself, and I don't see anything that repeats itself. So we're going to say none, or no mode, or doesn't exist, or impossible. Don't write the number 0, because if you put the number 0, that's a numeric. That would represent that 0 occurs most often, and that's not the case. So please make sure you put some kind of word association there. Okay. Find the percentile rank for 74. So we want, as a fraction, percentile rank means percentage below u. So it's a fraction, which means number of data that's below 74, because that's what we want to find the percentile rank for. And you divide that by the total number of data. So we just go through the list and count up how many pieces of data have a value below 74. And so we're looking at 57 is below, 52 is below, that's 2. 74 is not below, 70 is. So we're looking at 3 pieces of data out of the list that are below 74. And we're going to divide that by the total number of data. So that's 3 divided by 8. So in our calculator, we're going to say 3 divided by 8, 0.375. And we're going to move that over 2 to get a percentage, and we're going to say 37.5 percentile rank. That means that 37.5% of the data set lies below 74. Okay. All right, so D. I'll go over here a little more space. D is asking find the quartiles. Now finding the quartiles, we have to put everything in order, so we have to rank these. The quartiles are designated as, if I put a little thing here, just to give you a little background on quartiles. You're breaking the data into equal quarters. And this piece of data here is Q3, this piece is Q2, this piece is Q1. Those are your quartiles. And that breaks the top quarter and the bottom quarter and the 2 quarters in the middle. And so that's what we're trying to find. That quartile 3, which breaks the data into the top quarter and the next quarter, and quartile 2 is the middle, and quartile 1 breaks up the bottom 2 quarters of data. So we have to rank these. So I'm going to go back through my list, and I'm just going to go, let's see, over here on the side, I'm going to put in the data in a particular order. So if you can write down that data, if you want to have to pause the video for a second, I'm going to scroll down the piece of paper. And we're going to write over here on the side, we're going to write down this data in order. So I'm going to go highest to lowest. So we're going to say 96 is the highest, and then we're going to go down the list. So we're looking at 82 is next, and then 81 is the one after that. And then we have an 80. We're then looking at 74. We're looking at 70. We're looking at 57 and 52. 1, 2, 3, 4, 5, 6, 7. There's my 8 pieces of data. So what I end up telling all of my students in class when I teach this in my traditional classes is there's a formula for quartiles, but instead of doing the formula, I just simply do what is called the, it sounds a little dirty, but the 2-finger method, which is you put your finger on the top and you put your finger on the bottom, and then you just basically always find Q2 first, so work one at a time until you get to the middle. So we're going to move once, and then we're going to move twice, and then we're going to move 3 times. And so my top finger's on 80, my bottom finger's on 74. I need to get the middle, so that's between 80 and 74. So I'm going to put a line right here. And I need to find in between. That's the same basic idea as finding the class midpoint. You take the 2 numbers, you add them, you divide by 2. So that's going to give us back 154 divided by 2, and that's going to give us 77. That's our value for Q2. 77. So you always find Q2 first. After finding Q2, now Q2 is actually an imaginary invisible piece of data that lies between 80 and 74. So now 80 is the beginning of the top half, so we're going to do the fingers again. So we're going to put our our pen or our finger on 96. We're going to put our pen on 80, and we're going to work ourselves to the middle. So I'm going to move one at a time, and I end up in between 82 and 81. So I want actually to go between those two. You can tell that that's 81 and a half, and that's Q3. And then for the bottom, 74 is the top of the bottom half, 52. I'm going to work one at a time, and I have to go between 70 and 57. So we're going to say 70 and 57 divided by 2 to get the middle. So that's going to give us 127 divided by 2, which is going to be 63 and a half, and that's Q1. So for my answers for D, Q3 is 81.5, Q2 is 77, and Q1, that's a 7, and Q1 is 63.5. So there's my quartiles. So this first problem is just getting our feet wet with this stuff, and then we're going to have 3 more questions after this that you're going to be able to do all this stuff on your own also. So now letter E, we would like to find the interquartile range. The interquartile range, sometimes it's called IQR for short, is the highest quartile minus the lowest quartile. The word range always means highest minus lowest. And the highest value is Q3 and the lowest is Q1. That's why they call it quartile range. So you're just finding the highest minus lowest of just the quartiles. So we're going to take Q3, 81.5, and we're going to subtract 63.5, which is the lowest quartile, and that should give us back a very nice value of 18. That's the interquartile range. We're going to use that in just a second, because that seems a little weird that you haven't heard that before, but it's actually a very important thing that we're going to do. Here we go. F. We'd like to find what they call the lower fence. Now, after finding the lower fence for G, for F, we're going to find G, which we're going to find the upper fence. Fences are how we find outliers. Outliers are pieces of data that don't belong to the set. They're either really large or really small, and they just lie outside of what the normal pieces of data are. A typical outlier, in the United States would be the salary or the value of Bill Gates. Bill Gates, last year, I'm sure he made in the billions of dollars, and that obviously is an outlier when you reference that to everybody else's salary in the United States. So, stuff like that. So lower fence. Now, think of the word lower. So you start with the lower quartile. So we're looking at Q1 is the lower quartile. And to get outliers, you want to go lower than that. So you're going to subtract, and it's always 1.5 times the interquartile range. So it's always 1.5. That's just a statistical formula. So we're going to take Q1, which is 63.5. We're going to subtract 1.5 times the value we came up with for interquartile range, which is 18. So here we go on our calculator. So I'll clear off the screen. 63.5 minus 1.5 times 18. And we're getting 36.5 as our value. That's our lower fence. Okay. Our upper fence, so you think upper, the upper quartile, which is Q3. And then in order to get an outlier, if I go right here, outliers are always outside, so it would be way above Q3. That's why you're adding 1.5 times the interquartile range. So we're going to take our value for Q3. Our value for Q3 was 81.5. We're going to add 1.5 times the interquartile range, which is 18. So on our calculators, 81.5 plus 1.5 times 18. Okay, we're getting 108.5. And that's the upper fence. Okay, 108.5. Okay, make sure that looks good. So what we're looking at is any data, see now here for lower fence, let me get my pen. Any data 36, whoop, let me rewrite that, 36.5 or lower in the data set is an outlier. So anything that or lower, because lower fence, and then for here, for upper fence, any data 108.5 or higher is an outlier. So if you tie the outlier, you're considered an outlier. Or if you tie the fence, you're considered an outlier. So we look at our data set. It's actually right over here. And we're looking at, are there any pieces of data that are 36.5 or lower? No. So there's no outliers on the low end. And then the upper fence is 108.5. The highest we go is 96. So there's actually no outliers on the upper end. So when I scroll up here, I do it slow not to make you dizzy, it says state any outliers. So I'm going to scroll back down, if you bear with me for a second, and I'm going to say H, no outliers. Okay, I. I is asking us for the range. Range is highest minus lowest of the data set. So the highest, it's right here, the highest data set is 96. The lowest is 52, and we're looking at 44 as our range. We're going to talk more about range later in the next few weeks when we start talking about other statistical topics. But for now, it's nice just to know what the value is. And finally, draw a box plot. Another name for box plot is a box and whisker plot. A box plot in generic terms is basically, here is what it is. It's the lowest piece of data. So it's the lowest piece of data. And then you perform a box plot. So there's the box. And this is the value of Q1, this is the value of Q2, this is the value of Q3, and then you put in the highest piece of data. So that's a generic box plot. So for this particular example, the lowest piece of data is 52. You put a dot, you make a box, and then you put in your quartiles. Quartile 1 was 81.5, so I'm going to go over here. And it usually goes on top here. So this first line, you make it Q1, and then you draw a line in the middle. You make this Q2. The value we found earlier for Q2 was 77, so you put that on the top. Oh, I'm sorry, I did that wrong. This is Q1. I put in Q3. Q1 is 63.5. I apologize. 63.5. And then Q2, now Q3, which is 81.5. Then you go up here and you put a dot, and then you put in the highest piece of data, which is 96. So if you don't mind my small little mistake there, try not to do those too often, but that's a box plot. A box, obviously, because there's a box in the middle, and box and whisker because there's a box and then it looks like two cat whiskers going off each end. Now, I don't draw mine to scale. If you notice, obviously, there's a difference between 52 and 63 of about 11.5. And here, between 81.5 and 96, there's actually about 14.5. So this line should be a little longer than this line. But I really don't worry about that too much. It's informational. So as far as I'm concerned, so long as you put in the correct numbers and you draw it like a box and whisker or a box plot, people will understand what you're trying to refer to them. And they know that this is supposed to be the lowest, Q1, Q2, Q3, and the highest. Okay, so we did everything on that one. So here's what we're going to do. We'll take that one. That's a good starting point. Here's another example. And it says, a random sample showing the average length of a patient's stay at various hospitals in New York. And this is going to be in days. So we're looking at 7.0, 5.7, 5.5, etc. as we go down the list up to 9.9. And it's the same questions that we did before. Find the mean, mode, percentile, rank, and all that kind of nice stuff. So let's go through. Now, if you feel confident, then pause, please, right now. Do this question yourself. And then obviously turn it back on and see if your answers match the answers. We're going to do this for 4 things. So I'm going to go through here, number 2, number 3, number 4. And it's a good idea to pause, obviously, before you do these questions and see if you can get the right answers. That's always a nice way to do it. So here we go. I'm going to give you the answers. Okay, so the mean, which is x bar. We're going to add up all these numbers. Here's my calculator. Clear the screen. 7.0 plus 5.7. 7.0 plus 5.7 plus 5.5 plus 7.0 plus 6.8, 7.2, 6.4, and 9.9. Whoop, I hit a wrong button there. So we're looking at 65.1. Okay, if we add them all up, do that again, I apologize. So 7 plus 5.7 plus 5.5 plus 7 plus 6 plus 9.9 plus 7.2 plus 10 plus 6.8 plus 7.2 plus 6.4 plus 9.9. I apologize, I'm trying to look over my calculator to get all the numbers right. Okay, so we're looking at 88.6, and we're going to divide that by the total number of data. We're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're 88.6 divided by 12. Here's the calculator. So there's my 88.6. So if I divide that by 12, we're looking at 7.38. And we always go 2 decimal places in this class, so 7.38 is our mean or our average. Okay, find the mode. So for part B, we're looking at mode. We're looking at anything that repeats. Looks like we have a 7 here and a 7 here, and we're looking at anything else here. So 7 repeats. We're also looking at 7.2 and 7.2 repeats. Also, I'm looking at 9.9 and 9.9 repeats. And we're trying to look to see if anything else repeats. We have a 5.7, no other 5.7s, a 5.5. So we're looking at, this is a 3 modes, no particular order. So we're looking at 7.0 is a mode, and 7.2 is a mode, and 9.9 is a mode. So we're looking at 3 modes. That would be called trimodal. If there's only 1 mode, it's a mode. If there's 2 modes, it's a bimode, bi for 2. 3 modes is a trimode for 3. And anything 4 or more would be called multimodal. They don't add any prefixes once you get past 3. All right, so there's 2. C, find the percentile rank. So here we go. C, percentile rank. So this would be number of data below 9.9. And we're going to divide it by the total number of data. So let's see how many are below 9.9. We just go through the list and count them up. So any value that's below 9.9. So 7.0 obviously counts. So we're looking at 1, 2, 3, 4, 5. 9.9 doesn't count because it's not below itself. So 5, 6, 7, 8. We're looking at 8 pieces of data, and we're going to divide that by the total of 12. Total number of data. So if you say 8 divided by 12, okay, 0.6666. So we're looking at 0.67, or the 67th percentile. That's a fine answer. Because we're moving the final answer 2 decimals, if you wanted to say 0.666 and then a 7, you could say 66.67th percentile. Either one is fine as far as I'm concerned. And I will not make that distinction on an exam in terms of the decimals for percentile rank. I'm not going to give you both of these choices and make you choose. I mean, you'll see on the exam it'll be pretty clear cut on, either if I offer this one or offer this one. The other ones, the other questions won't even be close to those in terms of a correct answer. So D, let's see what we got here for D. We want to find the quartile, so we have to put everything in. We have to put everything in ranked order. All right, let's see if we can do this nicely here. So we have 10.0. We have a couple 9.9s and 9.9s. I'm going to cross out the data as I go here. We're looking at. We have a 7.2. We have another 7.2. We have a couple 7.0s. We have a 6.8, a 6.4, 6.0, a 5.7, and a 5.5. And if I did that right, we should have 12 here. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there's our 12. We're trying to find the quartile. So again, we put our finger at the top number and our finger at the bottom number, and we work one at a time till we get to Q2 first. So we're going 1, and then we're going 2, then we're going 3, then we're going 4, and then we go. Okay, so we end up with in between a 7.7 and a 7.0 and a 7.0. So Q2 is 7.0. So that's actually, even though it's the same value, it's actually an imaginary value, because notice there's 6 numbers on the top and on the bottom. So 7.0 is going to start our top half. So if I put my pen at the top, 10 and then 7, and I work one at a time to the middle, I end up in between 9.9 and 7.2. So I take 9.9 and I add 7.2 and I divide by 2. Okay, calculator. 9.9 plus 7.2 divided by 2. We're looking at 8.55. 2 decimals. That's our Q3. And then on the bottom, again, finger on 7, finger on 5.5, we work our way one at a time. And we end up in between 6.4 and 6.0. So we take those two. And that should give us back 6.2, and that's our Q1. So far, Q3, Q2, Q1. Okay, letter E. E says find the interquartile range. Interquartile range is the highest quartile, so it's going to be 8.55 minus the lowest quartile, 6.2. That's going to be 2.35. That's our interquartile range. We need that to find the upper and the lower fence. And for letter F, find the lower fence, and then G is going to be find the upper fence. So for the lower fence, we're looking at Q1 minus 1.5 times the interquartile range. Q1 is 6.2. We're going to subtract 1.5 times 2.35. So in our calculators, here we go. 6.2 minus 1.5 times 2.35. Okay, 2.675. We'll call that 2.68. That's our lower fence. For G, our upper fence, Q3 plus 1.5 times the interquartile range. Okay, our Q3 is 8.55. We add 1.5 times interquartile range of 2.35. Calculator, 8.55 plus 1.5 times 2.35. 12.075. So we'll call it 12.08. So any data, here's a data set over here on the left in order. Any data at or below 2.68, the lowest we go is 5.5, so no outliers. Any data that's higher or equal to 12.08, the highest we go is 10. So question H, I'm going to go here, ask for any outliers. We're going to say there's no outliers. Okay, I asked for the range. The range is highest piece of data, which is 10.0, minus lowest piece of data, which is 5.5. That's going to give us back 4.5. That's the range. And then J. J asks us to draw a box plot. So dot, we're going to put the lowest value, that's 5.5, line, box plot. Q1, which is 6.2, and then Q2, 7.0, Q3, 8.55, and then we're looking at the highest, 10.0. There's our box plot. Okay, Q3 would represent the data that breaks up the highest quarter from the next highest quarter. 7.0 is right in the middle. Q2, that's the upper half and lower half as above and below. And then 6.2 would be Q1, and that would be a quarter of the data is below, and then the other is above. All right, let's do number 3. Same questions. The cost per day of a random sample of condominiums in Maui from the Maui News. So the cost per day in money of a random sample. Obviously, we go from this is per day now, so we go from anything from on the low end $55 and $40 to pretty expensive things like $500 and $375. All right, same questions. Find the mean. Here we go. All right, so A, find the mean. We're going to add up the data. See if I can do it better than the last question. Okay, so we're looking at 50 and 68, and we add them up as we go. Okay, so we're getting 1284 for my total. We have 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. So we're going to take, 1284 divided by 8. We're getting 160.5. So that's the average amount of money of cost per day for a condo in Maui. Okay, so for part B, find the mode. Does anything occur more than once? Let's take a look here. It doesn't look like anything repeats itself, so we're going to say no mode. C asks for the percentile rank for the 68. So for this one, so we're going to say number below 68. How many number of data below 68? Total number of data. So how much data is below 68? 50 is definitely below 68. 55, that's 2. And 40 would be 3. So 3 divided by the total of 8. And when our calculators say 3 divided by 8, there we go, 0.375. So we could say 0.38, or the 38th percentile, that's okay. Or if you wanted to keep all the decimals 0.375, you would say the 37.5th percentile. It's all a matter of how much. I'm teaching you this semester, so as far as I'm concerned, I'll accept either one of those answers. That's fine, because I usually go just 2 decimal places. Again, on an exam, which would be multiple choice, I would not give you both of these as a choice for the correct answer. I would give you choices like 38th percentile, 63rd, 62nd, 50th, you know, something that would obviously be not very close. So you would know the correct answer. So hopefully that makes you feel a little more comfortable. Let's find the let's find the quartiles for letter D. So we're going to go highest 500, and we're going to work our way down. So 375, 125. I'm putting them in order. So 500, 375, 125. Then we're looking at 71, 68, 55, 50, and 40. 1, 2, 3, 4, 5, 6, 7, 8, and that matches 1, 2, 3, 4, 5, 6, 7, 8. Okay, so again, we're going to put our pen on the top and on the bottom. So pen on 500 and pen on 40. And we work our way to the middle, and we end up in between 71 and 68. So we're going to take 71 plus 68, and we're going to divide by 2. That'll give us 69.5. That is our Q2. So the 71 is here and 500 is there, so we're going to work our way to the middle here. We end up in between 375 and 125 divided by 2. Okay, so that looks like it's going to give us back 500 divided by 2, which is 250. That is our Q3. And then we end up in between 55 and 50. That's going to be 52.5. That's our Q1. Okay, so letter E asks for interquartile range. Highest quartile 250 minus lower quartile 52.5. Okay, 250 minus 52.5. We're getting back 197.5. Okay, so we're going to use that for F is the lower fence, LF. So we're going to take Q1, which is 52.5, subtract 1.5 times interquartile range. Okay, 52.5 minus 1.5 times 197.5. We're getting back negative 243.75. Obviously not anything's going to be lower than a negative number since we're talking about how much cost per day. But that's still a lower fence, regardless if it's negative. We just leave it as an answer. All right, G, the upper fence, that's going to be Q3. So we're looking at 250 plus 1.5 times 197.5. So here we go. 250 plus 1.5 times 197.5. We're looking at 546.25 as our upper fence. So now letter H asks if there's any outliers. And anything below that, no. Anything above that, no. So actually there's no outliers here. Nope, looks to be pretty good, no outliers. If there were, just to let you know, if there were any outliers, in real life what you would do is, let's say the 500 was an outlier, you would actually remove it from the data set and then you would recalculate everything else without that outlier, because outliers are not supposed to belong with the data set. So you'd kick it out, and then you'd find the mean and the median and the mode and all the other things that you would want to find without that. So you'd have to go back through and redo all of these calculations. I. I asks us for the range, so highest minus lowest data set, 500 minus 40, that's going to give us back 460, that's the range. And letter J, draw a box plot. Here we go. The lowest piece of data is 40. There's the box plot. Q1 is 52.5, Q2 is 69.5, and Q3 is 250. And then the highest piece of data is 500. Again, there's quite a bit of a difference between 69.5 and 250, but I'm just going to leave it the same width as it would be here because it's just informational as far as I'm concerned. You know, if we had to draw this thing by scale, it would get a little weird looking, but let's just leave it alone. So 40, 52.5, 69.5, 250, and 500. All right, that's number 3. All right, let's do one more. Okay, so here we go. Cholesterol level for randomly selected men ages 45 or higher within the United States. So here's the data set here, and let's find the same stuff. Again, probably be a good idea if you wanted to pause right now and then come back and see if we get the same answers. All right, here we go. So A, the mean. Okay, we're going to add this data set up. So let's see here. 262 and 236, 180, 96, 87, 184, 212, 333, that's a high one, huh? 194, 192, and 186. Okay, so we're looking at a total of 2162. Okay, 2162. And we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So we divide it by 11, we're getting back 196 point. Now if we look at our calculator, we're looking at 545. The third 5 is going to round that 4 up, so we're going to say 55. Okay, 2 decimal places and round whenever we can. B, find the mode. All right, let's take a look and see if anything repeats itself. So going through quick, we're looking at any other pieces of data. 192s, no other ones. 186s, doesn't look like there's any modes whatsoever, so we're going to say no mode or none. And then letter C, find the percentile rank for 262. So we want the number of data below 262. So that value is below 262. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 total number of pieces of data below that value, divided by 11 is the total number of data. So 9 divided by 11, we're looking at 0.8181. 8182. So we're looking at the 81.82nd percentile. Or if we just round to 2 decimals, we're going to say 0.82, and that would be the 82nd percentile. Either answer is okay. Okay. Let's look at letter D. Find the quartiles. All right, let's put these in order. So we're looking at 333 as our top, 262, 236, cross them out as I go, 212, 194, 192, 186, 184, and 180. 194, 92, 86, 84, 80, 96, and 87. All right, let's take a look here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. All right, so let's do it. Pen on the top, pen on the bottom. Pen on the top, pen on the bottom. This one's a little different now. Watch this one. Ready? So as we go one at a time, we're going to go 1 here, and then we're going to keep on moving 1 at a time, 1 at a time, and bammo, both pens actually end up on a piece of data. So that piece of data is actually Q2. Anytime you have odd set of data, you end up on a number, and you'll notice there's 5 above and 5 below. 192 is our Q2. Now the difference is, in the previous examples, I'll grab a sheet of paper here. The previous example we did, we ended up here. We ended up in between. So the imaginary number, so 71 counted and 68 counted in terms of still being in a data set. In this particular example, 192 is now out. It's out of play. That is actually Q2. That's the middle. So then when we start to do the upper half, we're going to actually start with 194 and also 333. And then we work one at a time, and we're going to end up right on 236. That's our Q3. And then we're going to start on 186 in our bottom half, because 182 is out. And one at a time, we end up on 180. And so there's our Q1. So Q1, Q2, Q3. All right, here we go. E. We want to find the interquartile range. Got it? So that would be highest piece of data 236 minus lowest piece of data 180, and we're looking at 56. F, we're looking for a lower fence, so we want Q1, buck 80 minus 1.5 times 56. So let's put that in our calculator. 180 minus 1.5 times 56. And we're looking at 96 as our lower fence. Anything tighter or lower than 96 is an outlier, because that's lower. Okay, lower fence is anything that or lower. Upper fence would be Q3. That's 236 plus 1.5 times the interquartile range. So again, in our pens here, we go 236 plus 1.5 times 56. We're looking at 320. Okay, 320. So anything at, here we go, anything at or below is an outlier. So when they ask for letter H, so tied, well, 96 actually ties. So this is an outlier. 87 is an outlier because it's below that. And anything at or higher than 320. So 333, we have three outliers. 87, 96, 333. Now, in this class, we're just going to state the outliers. And we're going to say that these actually are outliers. They don't belong to the data set. They're either too low or too high. They're outside of the normal realm of what an outlier, or what the normal data set is. In real life, you're supposed to kick them out. So over here, we would actually kick these numbers out, and then we would recalculate with the rest of the data set. We would actually recalculate the mean and the median and the mode and all the rest of the pieces of data, the pieces of statistical descriptive measures that we want, but we're not going to do that this semester. We're just going to simply just state the outliers, and then we're going to go forward. I, we want to know what the range is. So that's the highest piece of data minus the lowest piece of data. So 333, here we go, 333 minus 87, 246. That's the range. And then finally for letter J, draw a box plot. Here we go. So lowest piece of data, 87. Even though 87 is considered an outlier for our class this semester, we keep all the data. We label them if they're outliers or not, but we still keep them in terms of our answers. So Q1 is 180, Q2 is 192, Q3 is 236, and then there's the other whisker, and this is our highest piece of data, 333. So there's your box and whisker plot. I hope everybody did really well with all those examples. And let's have some generic questions now. So here we go. These are some questions I could ask you on exam number 1. And exam number 1 is going to be all multiple choice. So let's practice some of these questions. These are more just general terminology type definitions. Let's see what we got here. So a box plot. So I'm giving you a generic box plot, and I want to show you that even though a box plot seems simplistic, there's actually a lot of information you can get out of this stuff. So I have some questions on this box plot. It says, what is the median value? Now this is the box plot. So here's the lowest value, then Q1, Q2, Q3, and then the highest value. What is the median value? Well, the median value, if I put a little arrow over here, when you're looking at quartiles, and that's what a box plot gives you, Q3, Q2, Q1, 25% of the data is here, 25% of the data is here, and then here, and then the remaining 25% is then there. The median is Q2. So you're going to say the median value is 913. That's my answer. The range, which is highest minus lowest, they give you that. The highest is 1254. The lowest is 312. That's what represents the box plot. The highest and lowest are on the ends. And when I subtract those, we're looking at 942. So the range is 942. We actually can find the upper fence and the lower fence just from the quartiles, or from the box plots. Pretty neat. So let me go down here. For letter C, they're asking for the upper fence. Well, I need an interquartile range, so let's find the interquartile range. If you look at the box plot, the highest quartile is 964 and the lowest is 875. I'm going to scroll down again. Okay, so the highest quartile is 964. So in our calculator, here we go, 964, and we're going to subtract 875. Whoop, helps if I subtract. There we go. 89 is our interquartile range. So now we can calculate it. Upper fence, Q3, which according to the box plot is 964, and if I add 1.5 times 89, 964 plus 1.5 times 89, we're looking at 1097.5. That's the upper fence. If we do D, the lower fence, now we're looking at Q1, 875. We can get that right off the box plot. That's Q1. And we're going to subtract 1.5 times the interquartile range we just found a second ago. So here we go. 875 minus 1.5 times 89. 741.5. I like it. E asks, are there any outliers? Question mark. Well, there's no way for you to determine all of the outliers because the box and whisker plot doesn't give you all the data, but we can look and see if there are any outliers whatsoever. Now, if you notice, the upper fence is 1092.5, anything 1097.5, anything at that or higher, 1254 is definitely higher than that. So this is definitely an outlier. And then the same thing here, the lower fence is 741.5. That's definitely an outlier. So we know we have two outliers. We just don't know if there's any more because this doesn't give us the entire data set. But we definitely know we have at least one on either end because that's the lowest value, that's the highest value. So does the data contain any outliers? You would say yes, and you would then simply say yes, 312 and 1254, and then you might want to put a little note here, there could be more. But we don't know that because we weren't given the entire data set. Now, what is the value of the 25th percentile? That means 25% of the data is below you. That's what percentile means. 25 is percent below you. So that would actually be Q1. 25% of the data is below, right here, below Q1. So this is equal to Q1. That would be 875. So the value in the data set where 25% of the data is below would be 875. The 50th percentile would then be Q2, so that would be 913. The 75th percentile, if we go over here, Q3, 75% are below. So that would be the 75th percentile. And zero it, that means 0% are below you. That means you're at the bottom. And that would be the lowest value in the list. And of course, that is the first number in the box and whisker plot, 312. So that would be at the 0th percentile. You're at the bottom, and if you're at the bottom, nobody's below you, so you're at the 0th percentile. So that'd be 312. Here we go. The value 954. Does it lie in the upper half of the data? 954 would be somewhere in between 913 and 964, and that definitely is in the upper half, because this is Q3 and this is Q1, so that's the upper half. So that would definitely be a yes. And then what is the average for this data? Trick question. You can't add these numbers and get the average because they're asking for the data. And the box and whisker plot doesn't give you all of the data in a data set. It only gives you certain values of reference. So you would say the average of this data would be unknown. All data not given. And so that would be the answers to all of those. Almost done. Almost done. So here we go. A few more questions. I think we're doing pretty well. We're covering some good stuff. We're going to concentrate on percentile rank now. So here we go. If Sue is ranked 34th in her graduating class out of a total of 410 students, what is Sue's percentile rank? So if we have a total, I like to always draw boxes like this. So we have a total of 410 students. And she's obviously near the top because she's 34th. So I'm just going to put a little dot here and say she's 34th. Well, percentile rank for Sue would be number of students below Sue. And then you're going to divide that by the total number of students. So the number of students below Sue. So don't say 33, that's the number above Sue. So the number below Sue would be after 410. So if in our calculators we simply say, well, there's 410 total students. If you take away the 34 that are at Sue or above, you're looking at 376. So 376 are below. So now we can find the percentile rank. So you're going to say 376, and you're going to divide that by the total number of students, which is 410. So we put that in our calculator. 376 divided by 410. And we're getting back 91.71 percentile. Okay, so we used 0.9171. If we wanted to just simply say 0.92 to do decimals, then we'd say 92nd percentile. That should actually be an ST. 91.71st percentile or 92nd percentile. That's how we got that number below. Okay, let's look at the next one. Similar question. So why don't you try and answer this one, pause the video, answer this one, and then you can come back and see the answer. So, if Dixon finishes at the 12th as the 12th best runner out of a total of 980 runners in the race, what is Dixon's percentile rank? So again, if you don't have to draw the box, I like to. If Dixon is here 12th, out of 980, we need the number below Dixon, and we have to divide that by the total number. So 11 or above, don't say 11. If we're 12th, so there's going to be a total of 968 runners after Dixon finishes, since he finished 12th. So we're going to say number below would be 968. That's over the total, which is 980. So 968 divided by 980. 0.9878, 98.78 percentile. That's fantastic. You beat, or Dixon beat, 98.78% of all the runners in that race. I mean, that's pretty good. They may not like the fact that she finished, or he finished 12th, because maybe they're trying to win the race, but still, I mean, anytime you beat 98.78% of people at anything, that means you must be pretty good. So what is the percentile rank for Bill if he finishes 650th out of a total of 875 people on a standardized test, like an SAT or an LSAT or a PSAT or something along those lines? So if you finish 650, so you need the number below Bill on the test divided by the total number that took the test. The total number, of course, is 875. The number below, so 650th, how many are below to get to 875? You're looking at 225 are below. Okay, so 225 divided by 875, we're looking at 0.2571. 2571, so 25.7 first percentile. Okay, that would seem low, you only be 25%, but again, depends on who are you talking about. I mean, if you're talking about 875 people that are the creme de la creme of something, then you're still, even though a low in terms of that, but you're still considered creme de la creme. That's pretty good. I always like the question, I'll add one in here, I didn't write it down, but I always like the question, if everybody scored a 95 on the test, everybody scored 95 on the test, then what's the percentile rank for each person in the class? See, the teacher, if the teacher came in and looked at somebody in the class and said, you are this percentile rank, you'd probably go, oh, that's not good. Well, notice the number below would be 0. There's nobody below anybody. So the number below would be 0, and divide it by the total number. It doesn't matter what the total number is, but in this case it's 5. You're going to be at the 0th percentile. So that's what I'm saying. Sometimes these answers in statistics can be obscure to the point where you're thinking that they don't quite represent the data. If some teacher walked into a class and told a student, you're at the 0th percentile, the student would think, my God, I am at the bottom of the class. I am the lowest person in the class on the test. That's got to be bad. But then again, if everybody scored, like I said, everybody scored a 95, then, you know, everybody's at the 0, but that's not bad. The score is good. Or even if this was a 95 and this was a 96 and this was a 97 and this was a 98 and this was a 99, and I wanted the percentile rank for 95, that's still a 0. You're the lowest. But the grade is good. So the percentile rank may not look good, but the grade may look good. So you can definitely make statistics kind of manipulative in nature, just the way it works. All right, that's lesson number 2. Make sure you check out your homework, and I'll see everybody for lesson number 3.